Yes, hi everyone. So now let us we see the AC fundamentals. AC fundamentals. Yes, AC fundamental. So here there are two parts in the AC fundamental. So majorly two parts are there. So the first part is how to find RMS value, average value, peak factor and form factor. That is RMS value, next average value, peak factor and form factor. Yes, I will discuss in part 1. Okay. In the second part, I will discuss about how to find active power, reactive power, apparent power. That is before going to the active power, reactive power, apparent power. So first we can discuss what is steady state analysis of steady state analysis of AC network with sinusoidal excitation. With sinusoidal excitation. Okay. So I will discuss this in part 2. Okay. Part 2 and if possible part 3 also. So first let us see what is RMS value, average value, peak factor, form factor. How to determine these four for sinusoidal quantities and non-sinusoidal quantities. For sinusoidal quantities and non-sinusoidal quantities. So first let us find sinusoidal quantity, and before going to the sinusoidal quantity, so first we know we have to find out the formula for all these things. Yes, the first one is what is expression for the average value. Yeah, average value in the sense, so let us assume f is the function of time, then average value of f is given by 1 by t, where t is the time period, integral 0 to t f of t dt. Okay, so then what is RMS value? F RMS is equal to 1 by t integral 0 to t f square of t, or f of t whole square dt whole power half. Okay. Then what about peak factor and form factor? Peak factor is it is not power factor, it is peak factor, so which is given by peak value. It is the ratio of peak value to the RMS value. RMS value. Okay. Similarly, what do you mean by form factor? Form factor is RMS value to the average value. RMS value to the average value. So these are the four formulas to the average, RMS, peak factor, form factor. So now let us see how to find these four. So whenever any function is given. So first let us see when sinusoidal function is given. Yeah, let it be. This is the sinusoidal voltage. Okay, so let me assume it starts from 0, it is pi, 2 pi, 3 pi. Yeah, basically the waves are three types. The first one is it is unidirectional wave, bidirectional wave, unidirectional wave, bidirectional wave, and constant magnitude wave. Constant magnitude wave. Suppose, for example, first a constant magnitude wave in the sense it is considered as constant magnitude quantity. So for such quantity, the time period is infinity. Time period is infinity. And what about unidirectional wave? This is also unidirectional, but unidirectional regulator wave, which is like this. Used to observe in the case of outputs of the rectifier. So let it be this is 0, pi, 2 pi, 3 pi. So here what do you mean by time period? In the sense the duration of the quantity at which it starts to repeat is called time period. Yes, once again, what is time period? In the sense the duration of the quantity at which the quantity starts to repeat is called time period. So here where the quantity starts to repeat, you can observe that the quantity starts to repeat after the pi. So therefore this duration is called time period. So hence here the time period is pi. And here what about the time period? The time period is, so at 0 the shape is started. The same thing is started after the 2 pi. So hence this duration is called 2 pi. This duration is 2 pi. So that means the time period of this quantity is 2 pi. But generally, while we are calculating average value, RMS value, peak factor and form factor, so it is required to take the time period for unidirectional and fixed quantities in as it is. But whereas in the case of bidirectional quantities or alternating quantities or alternating current quantities, so we need to take only half of the cycle, because the next half cycle is similar to the first half cycle, but in negative magnitude. So that means just you observe here, whatever the area or region we have here 0 to pi and pi to over the pi to 2 pi, the same you can observe but negative magnitude. And whenever you try to get the average value, this is positive and here it is negative. If you add positive and negative, this will result 0. That will result 0. So hence in order to avoid the 0 value, so just we take only half of the cycle, that is 0 to pi only. 0 to pi only. So now let me write the function first. Yes, the first step while we are finding the RMS value, average value and peak factor and form factor is, first you need to write what is function. So let it be this is function, or let it be this is voltage V, and let it be this value is V max, Vm, and it is minus Vm. Okay. As it is the sinusoidal, therefore I used to write the voltage as voltage V is equal to Vm sine omega t. So where this axis is omega t. This axis is omega. Yeah. Wait 1 second. It is omega t axis and it is voltage. Yes, therefore this is V max. So hence I used to write this as V is equal to Vm or V max sine omega t. Now what is time period here? Time period t is equal to pi, which starts from 0, that is 0 to pi only. Okay, so now let me write the expression for average voltage, average value of voltage. That is, average value of voltage is V average is equal to yes 1 by t integral 0 to t V of omega t d of omega t. Okay, now you can substitute. What is 1 by t? 1 by time period is pi integral 0 to pi V of omega t is Vm sine omega t d of omega t, like this. Or you can also write this equation as Vm by pi integral 0 to pi sine omega t d of omega t. Now what is the integration of sine theta d theta? Integration of sine theta d theta is minus cos theta. So hence you can write this equation as, I should take this, V average is equal to 1 by pi, Vm by pi minus cos theta or cos omega t at limits 0 to pi. So now you need to substitute these values. This is minus Vm by pi cos pi minus cos 0. Now what is the value of cos pi? It is minus 1. Cos 0 is 1. So hence it is minus Vm by pi minus 1 minus 1. So hence this value is 2 Vm by pi. 2 Vm by pi. Yeah, this is average output, average value of the sinusoidal quantity. Yes, next. RMS. What is formula for RMS? VRMS is equal to 1 by t. First we write the expression. Integral 0 to t V of omega t whole square d of omega t whole power 1 by 2. Okay, so now let us substitute all these values. That is 1 by t. 1 by t, time period is pi here. 1 by pi integral 0 to pi v square, that means Vm square sine square omega t d of omega t, d of omega t whole power half, whole power half. So then here Vm square by pi integral 0 to pi sine square omega t d of omega t whole power half. Yes, now how you find out integration of sine square theta d theta? Yes, so how we can find in the sense? So simply I can write the sine square theta as 1 minus cos square theta or 1 minus cos 2 theta by 2, because we know that cos 2 theta is equal to, yes, what is cos 2 theta? Cos 2 theta is equal to 2 cos square theta minus 1 or 1 minus 2 sine square theta. Therefore sine square theta is equal to as 1 minus cos 2 theta by 2. The same equation I try to write here also. I will substitute here. Therefore VRMS is equal to Vm square by pi Vm square by pi Vm square by pi integral 0 to pi 1 minus cos 2 omega t by 2 d of omega t whole power half, whole power half. So now if I common, so now what is integration of 1 by 2? Integration of 1 by 2 d of omega t is omega t only, that is Vm square by pi integration of 1 by 2 is omega t by 2 at limits 0 to pi minus cos 2 omega t, integration of cos 2 omega t is sin 2 omega t by 2, already by 2 is there. Therefore sin 2 omega t by 2 into 2, that is 4, where limits are 0 to pi. Yes, whole power 1 by 2. Okay, now let us substitute the limits. So if you substitute the limits, you will get that is VRMS is equal to Vm square by pi, that is omega t by 2, that means pi minus 0 by 2 minus 1 by 4 into sine sine 2 pi minus sine 0 whole power 1 by 2. So here what is the value of sine 2 pi? Sine 2 pi value is 0, and sine 0 is also 0. Sine 0 is 0, sine 2 pi is 0. Then what is the remaining thing? Only pi by 2 is there. And even this can also written as Vm square by pi into pi by 2. Even pi also get cancelled. Whole power 1 by 2. So hence VRMS is equal to Vm by root 2. Just you do remember that while you are solving the problems in AC fundamentals, you need to remember this value. That is VRMS is equal to Vm by root 2. VRMS is equal to Vm by root 2. Okay. Next. Yes, what is peak factor? Yeah, peak factor. Yes, we know that peak factor of the voltage, V peak factor, which is equal to the ratio of peak value to the peak value is Vm to the RMS value. RMS value is Vm by root 2. So this root 2, sorry, Vm get cancelled. Hence it is root 2. Root 2 in the sense 1.414. 1.414. So you may get the question, that is, show that the peak factor of the sinusoidal quantity is root 2. Then how you can do? You need to find first RMS value, next average value. So then you need to substitute here. That is the peak value, and you can substitute here. So then what about form factor? Yes, what is form factor? Form factor is equal to VRMS by V average. VRMS is Vm by root 2 and V average is 2 Vm by pi. Vm get cancelled. Therefore this value is pi by 2 root 2. So here you should not substitute pi is equal to 180 degrees. You need to substitute the value of pi as pi is equal to 3.14. Pi is equal to 3.14. So when it is when the value of pi is 3.14, so then that is 22 by 7. You will get, that is 22 divided by 7 divided by 2 root 2. Yes, which is 1.11 you will get. 1.11 you will get. So this is the derivation for all sinusoidal quantities. That is, so here what are the results you get? V average. Yeah, the first one is V average is equal to 2 Vm by pi, and V RMS is equal to Vm by root 2, and V peak factor is equal to root 2. This is 1.414, and V form factor is equal to 1.11. Okay, and here so these are the values for all sinusoidal quantity. That means you may get the same value for this kind of waveform. For this kind of waveform also the same derivations you can make. And even if you take the cosine wave, you will get the same. For cosine wave also you will get the same. Okay, cosine wave also you will get the same. This is for sinusoidal RMS, average, peak factor, form factor for sinusoidal quantity. Then how we find for non-sinusoidal quantities? That is, for example, it is represented as like this. This is V 0 and let it be T. This is some capital V like that he has given. Then what is RMS, average, and RMS, average, and peak factor, form factor? So how we find these four for this given function? Yeah, the first one is, let us we assume the time period is T. Over the time period we have this value. Then how you can represent the V? First you need to represent the function. So function in the sense V of t is equal to, as we have written Vm sin omega t, here this value is constant. So hence I used to write this as V only. I will write this as V only. So if it is V, then what is time period? As time period is infinity for this function. So hence let me assume the time period is capital T. Time period is capital T. Okay. So then what is average value? V average is equal to 1 by T integral 0 to T V of t dt. Yes, we know that V of t is V only. So hence we can write this as 1 by T integral 0 to T V dt. That means V is constant. V by T. What is integration of dt? T. Related to. Yes, if you substitute that, this T get cancelled. So which results V average is equal to V only. V average is equal to V1. So generally in the electrical terminology, we used to consider this as the DC voltage, that is constant DC voltage, constant or fixed DC voltage. Okay. Then what about RMS value? VRMS is equal to 1 by T integral 0 to T V of t square dt whole power 1 by 2. So then 1 by t 0 to t. Now let me substitute what is V of t. V only, V square dt whole power half. And here you know that the value of V is constant. So hence V square by t, integration of dt is t at limits 0 to t whole power half. Yes, whole power half. So therefore it is given by V square by t. Yes, this substitute, if you substitute that, t minus 0. These two get cancelled. Whole power 1 by 2. So hence this value is V only. It is V only. So that means VRMS is V and average value is also V. That means you may get the problem. You may get the question such that prove that average and RMS value for DC is same. Prove that average and RMS values for DC voltage is same. So that means you need to do all these things. Okay, then what about peak factor and form factor? Obviously, peak factor is peak value, that is V, RMS value, it is also V, it is 1.0. This is minimum value of peak factor. And what is form factor? Yes, it is RMS by average. VRMS is V. V average is also V. This is also 1.0. This is also minimum value of form factor. Minimum value of form factor. So this is minimum form factor, minimum peak value. That means always the values of peak factor and form factor are greater than 1. Greater than 1. Greater than or equal to 1. So the minimum is 1 only. Minimum values are 1 only. Okay. This is about for non-sinusoidal. So I will discuss one more thing for non-sinusoidal quantities. That is, suppose they have given the voltage like this. So let me assume this value is T and it is Vm like this. Okay. Now what is the function? So first, always while finding the RMS, average, form factor, P factor, you need to find out the function of the quantity, given quantity. So that is V is equal to. That's how you can find the function. This is the line which is passing. This is the linear line, this straight line passing through the origin. That means here this point is 0, 0 and here this point is T, Vm. T, Vm. So now what is equation for the straight line equation for which is passing through the 2 points in the sense? Yes, we have the expression as y minus y1 into x2 minus x1 is equal to x minus x1 into y2 minus y1. Okay, or you can also write this as y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, so here this x-axis is t, so cavity x is equal to t and y is equal to v. x1 y1 0, 0, x2 y2 t, v, t, v. So therefore if I substitute these values here, then I used to get y minus y1 is, this y1 is 0, y1 0, x1 0, x1 0 and y2 is Vm, x2 is T. So hence you can write y as, that is y in the sense V as V is equal to Vm by T into Vm by T into x is T, small t. Vm by T into small t, capital T into small t. So now you need to find average, RMS, all these things for this function. Okay, so let us find. First one is average. V average is equal to 1 by T integral 0 to T V of T. V of T in the sense Vm by capital T into small t dt. Okay, so then, so here these two are constant, that is Vm by t square. What is integration of t? Integration of t is t square by 2. Limits 0 to t. Therefore, this value is Vm by 2 into t square by t square. So t square get cancelled. So here this value is Vm by 2. Okay. Now what about RMS value? Vm by 2 is average. RMS is VRMS is equal to 1 by t integral 0 to t Vm by capital T into small t whole square dt under the root. So this value is given by, yes, it is equal to 1 by t. Yeah, what is the square of this function? Vm and t are constants. So that means Vm square by t square integral 0 to t square dt under the root. Okay, so here t square into t is t cube. Therefore, this can also written as Vm square by t cube. Yes, what is this? What is the integration of t square? T square integration is t cube by 3. T cube by 3 at limits 0 to t. And if you substitute t, this t cube get cancelled. So hence VRMS is equal to Vm by root 3. VRMS is equal to Vm by root 3. Okay. So now we have RMS value and average value. So now I think it is very easy to find peak factor and form factor. That is, the first one is, what is peak factor? The peak value is Vm only. RMS value is Vm by root 3. Yes, therefore it is Vm get cancelled. It is root 3 only. It is root 3 only. Okay. Yes, then form factor. Yes, form factor is equal to RMS by average. That is, RMS value is Vm by root 3. Average value is Vm by 2. Therefore, it is 2 by root 3. Now, what is the value of 2 by root 3? 2 divided by root 3. Root 3 is 1 point, yes, which is given by 1.1547. 1.154. So that means you can observe that it is greater than 1, and even peak factor also greater than 1, because it is, what is the value of root 3? Yes, root 3 value is 1.732. So now here we have the various value for the function as like this. That is, average value is Vm by 2, or RMS is Vm by root 2, that's Vm by root 2, and peak factor is root 3, sorry, this is root 3, and form factor is 1.1547. Okay, yes, it is applicable for various waveforms like this. It is also applicable for this. The same derivations you can make. It is also applicable for this voltage. Okay, and wherever you have the triangular shape, so there you can apply. So that means even in some cases you have the waveforms like this also. That is, it is like this. For such waveform also, the same values you will get. I hope you got some idea about RMS value, average value, peak factor, and form factor. Yes, stay tuned and wait for the next episode. That is AC Fundamentals Part 2. Yes, thank you.